participant here in this session, which is related to which is a kind of webinar for and we are going to discuss about aging facilities and the approach related to risk-based inspection for the civil and steel structures. So we will be discussing different areas, and this is basically a webinar. So there are some guidelines that please mute your microphones to avoid the noise disruptions, and you can share your questions in the inbox during the entire session, and our panelist and the subject matter expert will answer them at the end of the webinar or during the session as well. So as Ms. Ikra already told me about some brief introduction of myself. I'm serving in SGS Pakistan as a team lead for the civil and structural inspections. Um, and I'm in the industry and environment division. And academically, I have done civil engineering from Mehdi University. And then I have done my master's in business administration from Institute of Business Management, particularly in marketing. I have almost 9 years of experience in the civil and structural engineering. I have led various projects in the SGS and the other organizations where I work in Pakistan and the projects in the Middle East. The most of the projects are related to the structural engineering and analysis and design and integrity assessment of the structures. I have done projects for the various sectors of the building and infrastructure, oil and gas, petrochemical sector, commercial sector, and the manufacturing industries. My area of expertise are, apart from the structures, I have done different kind of technical audits for the buildings and structures. I have expertise on the building information modeling. Similarly, I have also provided the services in the construction project management for as a project manager for the construction of one of the factory here in Pakistan. And also in the construction of well sites of the Pakistan Petroleum Limited. So here in this session, I have the panelist, my senior and manager from the civil services, Mr. Tanveer Ali. He is also a civil engineer and structure masters in the structures. Then we have Tahazia, again civil and structural engineer and serving the Middle East team for the LGS, and he is also a masters in the structures. So we are going to, this is the kind of detail of the program. We are going to discuss these areas. We'll be discussing the SGS, we'll be discussing giving basic introduction about SGS, then asset integrity management system and its components. We'll be discussing about the risk and risk management and its principles. We'll be talking about the significance of the risk-based inspection and then the criticality and potential risk for the civil structures. We'll be discussing the procedures involved in this RBI and some examples for the RBI inspections we have done, and also some kind of inspection strategies related to RBI. So then we will have a question answer sessions. Starting from the LGS, I will discuss briefly about LGS is a like group, and it's world leading inspection, verification, testing, and certification company, and known as Society General Anti Surveillance, and it was established in 1878 and currently serving in more than 100 countries. We talk about the timeline. It started from the 1878, where LGS was founded in France. Then the business was take off, and we opened new offices in the France and the different ports in 1879. In 1915, the headquarters was moved from Paris to Geneva, Switzerland. Then in 1919, the name was given as a Society General de Surveillance to LGS. Then in 1955, we start inspecting the industrial machines and goods related services. And in 1962, it was we established services for the oil and gas, chemical sectors, minerals industries, and the government institutions. In the 70s, we start providing the services in the area of environmental consultancies and remediation. And in 1981, we have increased our presence in different areas, and our sales also increases. And in 91, in fact, the booming economics in Asia fueled our growth, and we expanded our business to China as well. So in the 2000, our business further grow and our structure was further enhanced, and our SGS come as a leading position in inspection and business. So today we are operating in the more than we have 96,000 employees, and across the 2,600 offices and laboratories are actively working in the world. So this is our presence in the overall in the worldwide, in the America and the Middle East and the Asia Pacific, and serving the 160 countries. This is our presence in the Middle East in different countries like UAE, Turkey, Saudi Arabia, Kuwait, Lebanon, Jordan, and Oman, other countries. So these are the accreditation certifications we have from the different certification bodies and organizations which are related to ISO, IEC standards. Similarly, we have memberships and certifications, and we are approved from the approved inspector for KPI and NACE. Also, we have approvals from the for the Aramco, and we have certifications from the green building associations like these things. So this was a brief introduction about the SGS. Now starting from the our topic, coming back, it is related to the aging facilities. We are and the risk-based inspection approach for the civil and steel structures. So we will go step by step, and we will start from the bigger picture, and we'll then zoom it into risk-based inspections. So we'll discuss first the asset integrity management system. Asset integrity management system is basically a kind of a program in which, and if we talk about it particularly for civil and steel structures, it is a framework which ensures the reliability of the structures, the safety of the structures, and it ensures the availability of the structures throughout the entire life cycle. It identifies and assesses the safety environment and the financial risk which can be associated for the operation of the structure. It also establishes and maintains the suitable risk, and with the help of this program, we can further reduce the possible risk to our structures and assets. The design we produce during our structural engineering and during the even entire phase of engineering, it also assures the system that the design is fit for the purpose, and it is engineered to approve standards and as per and compliance to international standards. It reduces the risk to the person's environment. You can say like a financial risk, and also the reputation of the company. So these are some of the risk, and by the help of this program, we can reduce it. It also shows the overall integrity of the structure during all the phases of their life cycle, and assign the responsibilities to someone. So if we talk about the objective, it is to prevent the structure from the failures and the possible accidents. It can minimize the maintenance cost of the structures. With the help of a asset management system, if it is designed and developed efficiently, it can maximize the life of the asset, and it can also show the compliance with the regulatory requirements in code and standards. So talk about the components of the asset integrity management system. They are five in numbers, in which first we have risk assessment, then we have inspection and maintenance and documentation, then we have change management, and the performance monitoring. We will discuss one by one very briefly. That risk assessment is the kind of activity and phase in which we will conduct it to identify the potential issue that could comprise the structural integrity of the civil and steel structures. It can be from various factors. It also includes the identification of potential hazards and the likelihoods of these kind of hazards and the consequences. And in this way, the risk can be assessed, and if the risk is highlighted properly, identified properly, we can manage it efficiently. So we perform the risk assessment to identify all this risk and then efficiently manage it. Second component is inspection and maintenance, and it deals with the inspection of concrete structures and steel structures, and it can be bridges, it can be buildings, and can be a structure from the oil and gas structures like foundations of the equipment. And once we perform the inspection, and then on the basis of that inspection and the observations, we develop the strategies to maintain and repair the structure and to increase their life. The inspections include the physical checks and kind of non-destructive testing to detect any kind of damages and deteriorations. And definitely we will develop the repair programs on the basis of these observations. So once we perform the inspections, we usually noted down the observations we take during the inspections and maintenance activities, and then repair is carried out on the basis on the civil and steel structure in the areas of the weaknesses, whatever the damages the steel structure have or concrete structure have. If it is possible to develop a kind of repair strategy which can enhance the life of the structure, we can develop certain type of repair strategies. And if it is not possible to further enhance the life of the material, then there is another options to change the use of the structure or demolish it. So this is the point which I'm discussing, that this is a fourth component in which it is important to manage the changes to the structure, including the modifications and kind of refurbishments, reconstruction and demolition activities. This is all the decisions which are taken on the basis of the last three components, which is inspections and risk assessments and documentation. The purpose is to the changes do not compromise the asset integrity. For example, I can if a building is designed for a certain load, and if the solar panels are added on the roof of the building needs to be checked and assessed before the increment in the load. If it is not assessed and the integrity assessment of the structure is not performed, then there is a possible chances that we may have potential risk of the failure in the slab of the roof, because usually the slabs are designed for the life load of the persons, or like for the in case of the roof, because solar panels are installed on the roof, then they are designed for the solar and sun. So the structure need to be assessed properly. This is the fifth component, and which is to optimize the asset performance. It is critical to implement performance indicators and monitoring the system. And this component basically helps to provide data in the decision-making process and identify any trend that could lead to the failure. So in this stage, we really develop a certain type of indicators which help us to assess the condition of our asset, which is in our case civil and structure. So if there is a trend in which the damages are developing, then the cracks are emerging, then we can note it down, and our inspectors on the basis of their periodic inspections can share the document which help us to take the decision making, or the owners to take the decision for the changes. So overall, F integrity management system provides a structured approach to maintain the high level of reliability and safety of the civil and steel structure assets. So it's entire life cycle, and this is the goal of the overall F integrity management system. So before moving towards the detailed discussion on the risk assessment, and we'll discussing the risk, I just want to share, and we can just recall the concept of the reliability, which is about applying engineering theories to buildings and more generally structural analysis. And reliability is also used as a probabilistic measure of structural safety. And the reliability of the structure is can be defined as the probability of complement of failure. So if we have the probability of failure, which is dependent on the different type of failure modes and potential failures, which can be a structure redundancies, which can be a design problem, construction errors, which can be a number of inspections done, or which can be a kind of natural or disasters or kind of fireworks like these things. So the whatever the potential failure, we can develop equations and can on the basis of that we can calculate the probability of failure, and the reliability can be calculated as the complement of the failure. So failure occurs usually when the stress exceeds the strength. So the measure of the reliability is made by comparing a component's stress to its strength. The larger this gap between the stress and strength, the greater the reliability and the heavier the structure. So what is risk? If you talk about the risk can be defined as it is the possibility of something bad happening. And risk involves uncertainty about the effects, the implications of an activity on the future with respect to something that human value, which can be health, it can be well-being, wealth, property, or the environment. And the international standard definition of risk for common understanding is it is the effect of the uncertainty on the objectives. The understanding of the risk and the methods of assessment and management and the description of the risk and even the definition of the risk differ in different practices areas of, for example, in the area of engineering it is different, in the business it has different concepts, and in the economics environment the risk definition is different. Similarly, in the information technology, health, insurance, safety, and security, the risk have a little bit some different definition. But the overall, um, uh, you can say the concept is that the possibility of something bad happening, and the if risk is highlighted, we can manage to reduce the risk. The structural risk assessment is by the probability of the failure and its consequences. And failure can involve the whole building or bridge or a kind of another infrastructure, or can be involve a part of it or any structural component like beams, column, foundations. So we usually calculate the risk by product of the probability of failure and the consequences. The standard we use for the risk management is ISO 31000, which provide the principles and guidelines. So risk management have different parameters and components in which we identify, evaluate, um, cross control. We create awareness and we monitor the um, uh, and then implement them. So if we talk about the risk management, uh, it is the process of identifying and assessing and controlling the threats to any organization, the threats to the any asset, for example, machines like equipments, to electrical assets, to mechanical assets, and the civil category, the threat to any structure. These risks stem from a variety of sources, including the financial uncertainties, the legal liabilities, technology issues, strategic management errors, can be due to accidents and natural disasters. And we will discuss them in detail in the upcoming slides. And these risks can affect the people, the finance, the environment, and the reputation of the uh, organization. The process involved in the risk management have planning, identification, quantitative and qualitative analysis, response planning, monitoring, and control of the risk. As I discussed, the objective of the risk management is to increase the probability and impact of the positive events and decrease the probability and impact of the negative events in the overall asset life cycle. So in case of civil and steel structures, if we are going to reduce the risk and if we want to minimize the risk and manage the risk, then our target is to improve the condition of the civil structures or steel structures by a proper maintenance. And if this is done properly and time to time on the basis of the product maintenance, the structure can improve its life. So these are the principles of the risk management. In the first phase of risk assessment, we usually identify the risk, evaluate the impact on the organization. We evaluate the threats on the kind of threats on the organization, and also will evaluate the vulnerabilities and the can compute the risk level. Then second phase, we usually control and monitor the risk after the risk assessment, and we avoid the risk, we reduce the risk by certain measures. We can transfer the risk, as I have discussed that we can in the change management we can make certain decisions that the building and structure cannot cater the particular load, and we want to then can change the use of the that particular building. So similarly, in the controlling and monitoring, we have risk containment, and we can also perform the risk environment re-evaluation. In the risk reporting phase, we have three different activities in which we usually document the risk, we report the risk, and we make it the part of the overall risk management process. So this is on the left side, you can see the flow chart in which the steps are performed in the risk assessment model, in which there is an inspection program, and after the inspection program, there is a when the repair strategy were developed, it is in fact decided that on the basis of inspection that the structure need the repair, then we go towards the repairing program, and if they do not need the repair, then we can go towards the reassessment, and the cycle goes on. So till now, whatever we have discussed is a kind of like basis, which I have recalled the concept of the related to the risk, reliability, risk management program, and overall in a big picture asset integrity management system. Now we will be going to talk about the risk-based inspection approach for the civil FD. So RBI, in a short, we can say that is a systematic approach which is usually used to assess the likelihood and consequences of the equipment or structural failure. It is a kind of approach which usually, if applied, we can manage the risk associated with the civil and steel structures, and it involves a different kind of combination of statistical analysis and structural engineering expertise, including the structural analysis. It involves the material understanding of the material properties of mechanical and chemical properties, and it also involves the site-specific factors which are related to the constructions. So in case of civil and steel structure, RBA can be used to identify the potential vulnerabilities which can be due to structural design, inadequate structural design, and for example, the load taken for the design may be not suitable for that particular design, or and the building is designed for less load. And similarly, if one of the factors is environmental factor, and the third one is the construction issue. So these are some potential vulnerabilities, and we can, by the help of RBI, we can identify the problems which are related to the material degradations, the cracks emerging in the concrete structures and steel members due to extra loading or some kind of unplanned loads, and the corrosion and the fatigue in these structures. So if we talk about the importance of risk-based inspections, we can see in this picture that structures fall down and collapse due to the reason that the stakeholders and the authorities usually do not realize the impact of the possible impact of the certain load. For example, earthquake is a major concern if in certain location, then the structures need to be checked for that they are designed adequately to sustain the load of the seismic forces. And similarly, if the for example, the flood conditions, like in Pakistan, we have last year too many a large So the rainfall was very too high, and so due to which the flood conditions develop in the various regions. So it affects the substructure of the building, and if it is not properly addressed, we can lose the life of the people. We can have financial losses. We can have we may have environmental you can say issues, and also it affects the reputation of the organizations who are designing the buildings, who are constructing the buildings. And in fact, if we talk about the industrial sector, for example, if you have a tank and it have a ring wall in the bottom, if the ring wall is properly not designed adequately to cater the load of the tank, if it is not properly monitored and maintained, then the possible effect of the degradation, the deterioration of the structure, and if the corrosion emerges, it can affect the integrity of the structure, and ultimately it can cause a serious problem for the tanks as well, for the integrity of the tanks. And the settlement issues arises, and due to which there may be uh, leakages of the oil, which can contaminate the soil at the bottom and will affect the environment. So these are sometimes of you can say issues, and this is the importance of the risk-based inspection, that if you perform the inspections timely, um, then we can protect the many lives and assets. So the target is to identify the potential problems before they occur and allowing for the early interventions, and can develop a program for the prevention of these kind of risks and threats. It can also help to optimize the inspection and maintenance resources, which will ultimately reduce the cost and improve the safety of the assets. So if we relate the risk-based inspection approach in the maintenance plan, and so we have different techniques which can be used to define the inspection and maintenance plan for onshore and offshore structure. For example, an RBI, if we understand the whole structure and we know the whole lifetime of the structure, it can easy to predict the future requirements in the maintenance. Similarly, maintenance of an existing old buildings and its relation with the cost of repair need to be considered during the maintenance plans, and the lifetime of the maintenance or the protection of the structure must be taken into consideration. So the required time to perform the maintenance must be discussed thoroughly. We can say that if to maintain an existing old buildings and restore the structure to its original strength, the repair method of rehabilitation is also governed by the initial cost of the repair and the number of times the maintenance will be performed, and its cost over the remaining life of the structure. Usually, the lifetime of the maintenance or the protection of the structure must be taken into consideration. So the required time to perform the maintenance must be discussed thoroughly. And the first step usually is to calculate this particular time, that when maintenance need to be performed. The process of determining the time of the maintenance actually depends on the maintenance cost estimate versus the structure probability of failure. These are the two basic factors on which it is dependent. Yani time of maintenance is dependent on these two factors. So it is important to decide on the selection of the appropriate time to perform the maintenance. The process of decision making by the authority or the stakeholder, you can say, will be clarified, and how to use it from the standpoint of determining the right time for the maintenance. This overall procedure is known as an optimization procedure, in which we usually calculate the exact time on which the maintenance should be performed, so that the extra cost can be reduced on the different factors. So after that, this is the kind of graph in which I wanted to show and discuss that the stages in the deterioration of the concrete structures with respect to the time. Usually, when the uh, we design the structures for some certain life, for like 50 years or for 100 years for some kind of specific structures, special structures. But if the structures are not properly maintained and monitored, the concrete deterioration really started. And with respect to time, the time comes when the chloride concentration or carbonation processes are started. Then after that, the third stage is when there is a starting of corrosion in the rebars and the steel reinforcement of the structures. Because once cracks are developed, when there is a penetration of the chloride content on the concrete cover is carbonated, then the spoiling of concrete is started, and the cracks from these cracks, water moisture go inside and can further deteriorate the concrete as well as it start corrosion of the steel reinforcement. And once this happens, then after that the cracks further appear, and the width and thickness of the crack further increases, which results in the spoiling of the concrete, and it start complete deteriorations. So similarly, if you talk about the reinforcement, you can see that usually we have without the corrosion, the rebars have minimum nominal diameter. But when the corrosion starts, and the degradation process started, then the material degradation due to the moisture or oxidation, the material starts disintegration, and it results in the capacity loss in the reinforced concrete sections. If we talk about the fundamental of the design of the any reinforced concrete member, the member's capacity is dependent on the cross-sectional dimensions of the concrete and steel area, and the material strength, concrete strength, and steel yielding strength. In the case of uniform corrosion, as you can see in these figures, that the total longitudinal reinforcement area can be expressed as a function of time, and where T is showing as the time, and D is the diameter of the bar, and these equations, and N is the number of bar, where Ti is the time of corrosion initiated, and the Cr is the rate of corrosion. So equation 11.2, as mentioned here, is it takes into account the uniform corrosion propagation process from all the sides, and overall over time the collapse of the structure is more likely with the increase in the rate of corrosion. So in these curves, you can see that we highlighted the pattern of the deterioration of the steel reinforcement. In these two slides, in these 34 number slides and these 35 number slides, this slide is particularly in which the reinforcement ratio, if you see in the bottom, we have 1% ratio. And we are talking about this particular structural element, which is the column. So in the column, we have a range from 1% to 8%, but usually it is taken from 1% to 4%. So if there is a lower reinforcement ratio, which is 1%, then the reliability versus time graph shows that it in different corrosion rate. For example, at the minimum rate is 0.064 is considered millimeter per year, and the maximum is 0.114 millimeter per year. So these in this graph, you can see that in the from 0 to 10 years pattern, we have a value of reliability from 4 to 5, and then from 10 to 20 years it reduces, and then from next 20 to 50 years it's constantly moving. But in the next slide, you can see that if the reinforcement ratio is increased to 4%, then from 0 to 10 years, the value of reliability is again more 4, again in fact more than 5. but it means the reliability is improved. But when it moves from 10 to 20 years, it reduces, and after the 20 to 50 years, it reduces gradually, and it is not a kind of a constant curve. So in these cases of we understand that, and that if in case of higher steel ratios and lower corrosion rates, this period may increase to about 15 to 20 years. Moreover, this study expects that in case of columns with eccentricity, the movements on the column will increase, so the design should increase the percentage of the steel. In such cases, it is expected that the deterioration of a structure towards criticality will ensure after couple of years in the cases of lower reinforcement steel ratio and very high corrosion rate. And on the other hand, as in this graph, you can see that in the case of higher reinforcement ratio and lower corrosion rate, the maintenance will be due somewhere around after like 5 years and 10 years. So this is what we wanted to explain, that over time the collapse of a structure is more likely with the increase in the rate of corrosion. So these need to be considered and during the highlighting the risk. So in this section, we can see that this is a calculation for the time which is required for the corrosion, and in the cases of the structures exposed to chloride, the time required for spread of chloride in the concrete until it reaches the steel is the time required for the corrosion. It is also important to consider that in the case of structure exposed to carbonation spread inside, the concrete cover and several equations can be used to calculate the time required for this proposition. And to calculate the depth of the carbonation transformation, the equation which is D equals to A into T power negative 0.5. This equation can be used to calculate the depth of the carbonation, where A is the fixed amount depending on the permeability of the concrete as well as the quantity of the carbon dioxide in the atmosphere. And there are further several definitely factors. So similarly, in this equation, in which the second equation, we have water cement ratio, W upon C, and which is and S is the effect of the cement type, and capital W is the weather effect. This equation gives the average depth of the carbon transformation, and therefore, when calculating the maximum depth of the transformation carbon, one should increase the value from 5 to 10 mm, and S can be taken as 1.2. So these are some values which can be taken, like capital W, which is the weather effect, can be taken as a 0.7 in case of concrete protected from the outside environment. So these equations can be used for the calculation of depth of the carbonation. Similarly, if we talk about the last equation, this is the equation of Kamel. And is used to calculate the time necessary for the beginning of corrosion to the emergence of effects of the corrosion on the concrete in the so DCR is the CR is the corrosion rate, capital D is the diameter, bar diameter, and capital C here is the concrete cover thickness, where T is the TS, which is like on the left side, is the time from the beginning of corrosion until the concrete cover falls down. So the total time expected to perform the first repair depends usually on the time of beginning of corrosion. Whenever the corrosion is started, it begins. This is the first time which you can say the total time expected to perform the first repair depend upon this one of the factor. In addition to the time needed to increase the rate of the corrosion to cause the concrete deterioration and to perform the repair. So these are some kind of methods to calculate the time required the query. This graph basically shows, as I have discussed previously, optimization procedure. Um, so you can see that for the reliability is on the x-axis and the expected cost is on the y-axis. So it is the cost is depending upon the reliability. If And you can see that if you want to reduce the cost of deterioration, or in other words, to optimize the life cycle of the cost of the structure, a balance need to be achieved between the benefit of the risk reduction by improving the designs and maintenance, and the can include the inspections and the cost associated with these measures. So if we can see that if we talk about the failures and the risk cost, if the reliability increases, the expected cost, the red curve shows that the cost will be reducing. And if the blue curve shows the maintenance cost, definitely if we are going to increase the reliability, then it will require the number of inspections, periodic inspection plan, and the maintenance plan, which may require the 3 years or 5 years inspections. So it will definitely increase the cost, but ultimately it will help to, in fact, increase the reliability. So if the reliability is less, then expected cost is too high. But if the reliability is increased, then total cost will be as much lower than the expected cost. So this is the what we want to show here by the help of this graph, that if the organizations considered this as a important parameter and important factor, that if they want to increase the life of their structure and assets, then or in other words, if they want to increase the reliability, they need to develop a proper maintenance program for the civil and steel structures also. Because these are they have equal importance in comparison to mechanical and electrical assets. These assets, the foundation, the structures are providing the shelter, and these they collapse if they are not designed adequately, if they are not maintained. Then ultimately your machines, your equipment, your people will suffer. So this, now we're going to talk about the process of the risk-based inspection for civil and steel structures. So it involves to identify and define the critical components of the structure that are important for safety and reliability. It covers the by the help of the second is to determine the potential failure mode for each component, and the third one is to determine the probability of failure for each failure mode, and then to evaluate the consequences of each failure mode. Then fifth is to assign a risk ranking to each component based on the probability of failure and the consequences of the failure. And the sixth is to determine the appropriate inspection and maintenance strategy for each component based on the risk ranking. So we quickly move on. The calculation of the probability of failure and its consequences to obtain the structural risk is usually called as the qualitative risk assessment, but we can also perform a quantitative risk assessment in which we calculate the numbers, and on the basis of these numbers, we can develop risk matrices. So one by one, we will discuss these process involved. So in the identification of the risk, we need to uh, identify what are the risk threats and weaknesses in the existing building structures. From the design to execution, you need to think and plan that if the design is adequate, if the construction material used is tested and reliable, if the construction installations are as per the code and standard engineering practices, if your structure is safe and stable in case of any changes. These are some pictures for related to the pre-engineered building, the civil concrete structure, high-rise building, industrial plants, and the fuel utility stations. So the principal weaknesses in the buildings on the structures can be due to the lateral loads and the lack of resistance or capacity to resist the lateral load, the inadequate ductility of the which can cause insufficient confinement of the longitudinal reinforcement. Uh, Main causes of the ductility is the confinement of the longitudinal reinforcement in the beam column and slab column junctions or joints. It can be a tendency to local overstressing due to complex and irregular geometry in plans and elevations. The poor quality material in the work construction, and one of the factors is aggressive environment due to chloride and sulfates and penetrating the reverting the corrosion of the rebar. So you can see the collapse of these buildings and the fuel retail stations and other by the this happens because if the buildings are not designed adequately or they're not constructed properly, then they can be affected by the impact of the loads, the load of the seismic activities, effect of the storm and heavy rains, high speed winds, flood and rise in the groundwater table, the corrosion and rusting in the steel structure, deteriorations in the concrete foundation, deterioration in the building, impact loading when heavy force in a short span of time affect the structure. It can collapse the structure, and the fire exclusion in the industrial sectors is very common. You can see the impact of the fire in the steel structures as well when the structures are not properly constructed. Like fireproofing can perform here to minimize the risk of the fire, but as you see, it was not done. So that's the impact of the burning, and the effect of the load, impact load, as well as the effect of the wind loads can be is very common in the steel structures if they are not designed adequately. And similarly, the effect of the earthquakes and seismic activities for the oil and gas sectors, especially for the offshore structures, the structures under the sea is very important to be monitored periodically to avoid the corrosion, the start of the corrosion, and the CP system for to control the corrosion need to be monitored, especially. Uh, Second is determination of the potential failure modes. It can be redundancy of the structure. It can be age of the structure, the expertise of the designer, it can be expertise of the contractor, the code and expertise to develop a maintenance plan, and the last inspection conducted. So these are some potential failure modes which are can be considered as to determine the probability of failure. So determination of the probability or likelihood of the failure modes can be calculated by these tables. You can see that if in the structure is whenever the structure is constructed after 10 years, there is a probability of failure 9%. Then 20 years, after 20 years, it increased to 25%. And with the passage of time, you can see after 50 years, there is a 91% probability of the failure because the material usually degrades. And if the maintenance is not properly managed, then is the chances of the failure in the structure. In the second table, you can see the different failure modes, and there is some kind of ranges in which you can quantify them, the level of their the risk associated with them, and then when you quantify them on the basis of expertise and judgments, engineering judgments, then you can these S1 to S6 are different kind of structure taken as an example, and the factors subtract from the structure probability of failure are assigned accordingly, and then the total score is calculated structure-wise. Then, in order to calculate the consequence of the failure of the mode, we need like different six structures are taken as an example. The impact on the person, impact on the cost, impact on the environment, and impact on the reputation. These are again numbered from the ranges from 1 to 10, and these are assigned as per the expertise that what is the consequences and how much the person will be affected, how much cost it will be when this particular structure is damaged. For example, if the ring wall of the foundation of ring wall foundation of the tank is damaged, it will definitely affect the whole tank full of the crude oil or other material. Similarly, if the foundation of the structures, high-rise building is affected, or if the pile of the offshore structure is affected, then it will definitely cause harm. But for example, if the cantilever slab of any projection is affected, then definitely it will have a less impact on the environment, or like minimum cost will be taken to reconstruct it. So these are some factors which need to be considered and which are considered during the calculation of the consequences. Then we have a evaluation of the risk ranking based on the probability and consequences. Again, remember that when you are calculating the risk, it is the product of the probability and consequences. So the risk weight lift for all the structure, you can see that the probability of failure was calculated from the last this table, and then consequences are calculated from this table, and they are together in the two different columns are placed here. And then by the product of these probability of failure and consequences, we get the number risk. These numbers are very important because on the basis of that, we can categorize them in the priority wise. And the priority means like we can give importance, high importance to that particular structure, which is in red category, then in yellow category, and then least importance given to green category. Step by step, you perform the maintenance and repair strategies are developed accordingly. So you can see here, this is a kind of example. Okay. So, but after these calculations, you can develop a kind of risk matrix in which on the bottom you have a consequences, on the vertical axis you have likelihood or probability of failure. So you will then categorize them and can also assign them a particular color on the basis of the priority. So I'm sharing the one of the example here that of the oil and gas sector in which we have taken some kind of observation for the fuel retail stations, and you can see that there are number of observations which are related to the unavailability of, for example, oily water separator, for the unavailability of the catch pits, boundary wall is not available in some cases, canopy structure was not available, for example, and similarly, the thickness of the RC slab of structure were not sufficient. So these are some observations, and after these observations, each observation was um, considered, and the likelihood was assigned, and the consequences was also assigned. So the likelihood deals with the this can happen very likely. If it is can be happen repeatedly, then we will find a 3 number. And similarly, there is if there is a possibility to occur intermittently, then there is a 2 and with the yellow color, and if the less likely, then it is a 1. The consequences on the people, you can see here, there were 3 different columns in which if the minor consequences is the possible, if the people are affected and there is a requirement of first aid, and not affecting the work performance and not affecting daily life activity of a person, and the illness with reversible health effects such as food poisoning and determinants. So these are some guidelines in which if the people is affected in this category, then it is the minor and one consequences is taken. Otherwise, if it affect the performance in the longer term, such as absence from the work for the 5 days as well, for example, then it is considered moderate. And if it is resulting in injury or occupational illness, or a kind of car accident or multiple, you can say, for example, cancer to a large explosion population. So these are some factors which are considered a catastrophe for the impact on the people. Similarly, if we talk about the environment, if no environment impact contained within the premises, then we have a minor. If a limited environment impact that will persist, then we can take a moderate. For example, spill onto a non-impervious surface that require removal and disposal of large quantity of surface media. And if there is a severe environmental impact that requires the extensive measures to restore use of environment, then it will be taken as a catastrophic. For example, if the on-site groundwater is contaminated by the, for example, in case of oil and gas sector in terminals in the depots, if the oil tank and the vertical tanks are leaked, and if the dike area is not constructed properly, and if this is like natural ground, and if there is a nearby water body, then it can affect the water body as well. So this will be considered a catastrophic. In third category, third consequences, we have a finance, for example, cost up to 1 million USD, and then more can be as a minor, taken as a minor for moderate in between the 1 to 10,000 to 1 million USD. Then a cost exceeding 1 million USD is taken as a catastrophic. This is the impact on the finance. It means if your structure is damaged, if your building is damaged, what will be the effect on the finance of the organization? And it is not only limited to the cost of the asset, particularly. It also gives, for example, you can see if the operation is disrupted, then if the total loss of operation, then it will consider as a catastrophe. But if the operation can be resumed after some days or short time, then it can be taken as a minor. The last is the reputation of the organization. If the damage of the asset can is negligible and it can be at no local level, no local media coverage, no public awareness with no concern, then it can be taken as a minor. But if there is extensive coverage in national and international media due to the affecting the, for example, there is a casualties of the people, or there were extensive damage to the infrastructure, then can be taken as a catastrophic, because it will affect the reputation of the organization, or maybe it can cancel the license of the organization if the damage is so high. So these are a kind of consequences. This is a kind of on the basis of last 3 to 4 slides. This is the outcome. That on the left side you can see the observations. Then there is a likelihood column. Then we have consequences on the people, environment, finance, and reputation. And there is a risk score, which is also showing the color of the risk, and also with the number giving the priority. For example, red color showing that the priority is given to these particular observations, immediate basis, and the repair and maintenance strategies which should be developed. So after this risk matrix, we have 3 to 4 slides remaining, in which we will be discussing about the inspection and maintenance strategies. So the decision-making methods of an engineering project have been the focus of the, you can say, numerous studies in terms of their economic and financial importance to the cost of the project. And because any wrong decision, any false assumption could result in spending a huge amount of money to further reverse the consequence and effect of this damage. So some studies have used decision trees to determine the appropriate time for the repair, particularly in some case of infrastructure bridges, and that it required the product inspections. When performing the maintenance plan strategy based on the cost, we must consider all the factors affecting the corrosion in general, and other factors affecting the structural durability and reliability. For example, any method upon which a decision is based should define the time for the regular maintenance and inspection, such as 10 years, 15 years, or 20 years. This decision is made first and foremost through the identification of the least and expensive option. So this is the main, you can say, a way forward, that the decision is made first and foremost through the identification of the least expensive option. Okay, this graph you can see here shows the and basically summarizes the reliability of any structure with respect to the its lifetime. That really the structures, when they are constructed with the passage of time, they degrade, and if the inspection is performed and they are maintained properly with a regular interval of time, then on the basis of the repair and maintenance, their life is further increased till up to the initial level, and then again they start degrade, and then still after certain level of time, if you perform the inspection and perform the repair, then again their life further increase, and this process go on. So the periodic maintenance inspections and regular repair and maintenance, if they are performed efficiently as per the management, as per the maintenance plan, and strategies are developed efficiently and implemented effectively, then the it will revert that the structure or the civil buildings or whatever the asset you have, it will the reliability of that asset will increase, and throughout its life cycle, and it will give you better options. for the rest of the operations. So similarly, if you talk about, there are some parameters in which you can see that inspection itself is not only can improve the reliability. This is another aspect. It is accompanied by a corrective action in the event that a defect is discovered. So several policies and strategies used in the wide range for the great structures which have been programmed. It can should include the monitoring until the cracked depth reaches a certain proportion of the material thickness, and then repairing them. Immediately repairing upon a detection of the indication of the damages. Then third is the repairing at a fixed time, for example, after 1 year after detection of indication of damage, and repairing as a new, for example, repair the welding for this in case of a steel structure. These are some criteria we can say that for all kind of corrective actions, but depending upon the level of the damage or level of the, you can say, deteriorations you observe in your structure, you can plan the repairing program accordingly. For example, if there is a large and heavy severe level severe crack, then you need to, and there is a chance of collapse of the structure, then this is a highly alarming. So you need to take decisions accordingly. But if there is a moderate level crack and you can repair them, then you should apply the repairing strategies in a short span of time. But there is a, if there is a minor level cracks, then you can take some time to repair them and can consider them as a less important. Another graph, this is, you can say it is assumed that the inspections are performed at a constant time interval, since the inspection authorities often prefer a constant inspection interval to facilitate the planning. From this point, the inspection intervals are uh, chosen so that the expected cost of inspection, repair, and failure is minimized. So if for example, 3 years, some companies decided that we are going to perform the inspection after each 3 years. So this will give them a kind of confidence that, okay, if there is a no unplanned or no extra load, and if the structure is stable as per the design load, then we can perform the inspection after the 3 years and can check the level of our the reliability of our structure and the condition of the structure. So this will help them to minimize the overall cost of the failure and damages. So it is good to plan to develop a kind of program in which you have a specific interval for the inspection of your assets related to civil and structures like foundations, columns, beams, slabs. For example, you can see in the next slide. Um, Although most concrete structures inspections techniques are visual or based or involve various kind of non-destructive techniques, which will be discussed in the upcoming slide. But the ability to detect the damage depends on the quality of the inspection you are performed. So qualified inspector is very important. Who is performing the inspection, whether he is certified, he is qualified to perform this inspection, because life of the people, finance, environment, and like reputation of the organization is depending upon the observations which he or she is really taking from the site. So experience is very important. The higher quality inspection method will provide a more dependable damage assessment, and no repair will be made unless the damage is detected. In case of the other structures such as steel structures, general inspections usually include the uh, visual inspection, as well as non-destructive techniques may include the magnetic particle induction inspections, MPI techniques, and DPT, UT, radiography, and hardness testing. And there are some kind of on-site chemical testing like PMI. So these are some tasks usually performed in the field structures. For the offshore structure, okay. In case of the offshore structures, like we have different rigs for the oil and gas, and then we have jetties and trestle bridges. So we usually perform the inspections of these kind of structures. SGS is very have expertise in performing the inspections of these structures. So in these type of inspections will be performed on the top side, similar to field structures on the onshore. But you can see the jacket of the platform must undergo underwater inspection. And the underwater inspection, which occurs high cost, can be performed by the divers, which should be expert in taking the observations and pictures and videos, and also by remote operating vehicles like ROVs. ROVs or divers perform visual inspection to detect the flooded members, define the location of the damage or band members. They define the thickness of the marine growth around the piles, in fact, and near the cathodic protection readings as well underwater. So in case of offshore structure, it is very important because the piles are penetrated deeply under the sea bed, but the area in between the sea surface and the bed of the sea is highly critical because the effect of the corrosion is very high if the CP systems and other your remedies are not properly addressed. So these type of appropriate inspections and maintenance strategies are need to be defined um, uh, to inspect them. Whether the board should be used to check the fuel condition. There are still right now some technologies like SGS is using. For example, we are using the drone for the inspection of the above the seawater structures right now in Karachi to detect the damages closely. And by the help of the drones, we minimize the risk to our inspectors as well. So this is the way forward in the help of the digitalization and innovation. We can use the technology to take the better results of the damages and possible risk to your structures. Yeah. So these are, you can say, a visual inspection performed on the basis of in ISO 13822, which give guideline about the inspections, and ACL 201.1R for the concrete structures, and American Institute of Steel Construction guidelines. And there are definitely other standards which can be used for the inspection of the structures. The non-destructive and destructive techniques usually we use for the concrete structures and steel structure. You can see the list of these techniques which have ferro scanning, strength, Schmidt hammer testing, the corrosion analyzer. We have like chemical testing for the hardened concrete. Then for the steel structures, we can see the MPI, DPT, UT, hardness, and chemical testing for the steel structure. These are some kind of destructive, non-destructive testing to check the condition of material and the quality of the material for that the further to calculate the risk of and probability of failure. So these are kind of softwares and in fact the code and standards which can be used. For example, IMS Civil is used for to calculate to perform the structural integrity assessment. Then start code, SAP 2000 tabs, and the Revit structures are used to analyze and model the steel structures and concrete structures, and to check the behavior of structure and the existing condition of by incorporating the existing condition of material, and to predict the behavior of a structure on the basis of the load. So the conclusively, if we talk, we discussed that the use of the RBI and the risk-based inspection approach, it will help to identify the potential problems with the civil and steel structure before they occur, and they will allow the for early intervention and preventive maintenance. It can also help to optimize the inspection and maintenance resources to develop the best strategies for the repair and maintenance, and it will definitely reduce the cost, optimize these systems, and it will improve the safety of the civil and steel structural assets. So this is all about the risk-based inspection approach. I understand that the 1 hour time period is very short for this. You can say a huge topic, and there is a much more which can be discussed, and which so we are regularly conducting these kind of webinars on different topics of structures and civil and steel structure. So I hope you guys can further attend these sessions to increase your knowledge and awareness in this area. If you have any questions, we are here. Our manager, Mr. Tanvir Ali, I am myself, and Mr. Tahaji is here. Can share with us via emails as well as you can discuss like forum. That's all. Thank you.